All right, y'all. So 2.2 deals with functions. So we'll start out. I'll give you definitions on our domain and range and a function. Then we'll work some of them problems, okay? Then I'll get y'all into what we call function notation. So the first thing is our domain. So y'all, the domain is the set of all x values, which could be the inputs, okay? So it's the set of all the x values or the inputs. Then we got the range. The range will be the set of all y values or outputs. So, y'all, let me give you an example of a domain and range. So, say we were looking at someone's pay. Okay. So, your pay is going to equal how much you make an hour. So, your salary times the number of hours you work. All right, y'all, let me let some in real quick. So for a problem like this, my domain would be the hours I worked. And I can work usually anywhere from 0 to 40 hours. Now, the range will be the actual pay you received. Okay. So remember, the domain is the inputs. When you're looking at your pay, your input, like we said, would be the number of hours you worked. And the range is the pay you're getting for those certain hours. All right, so now let's look at a correspondence. So a correspondence shows a relationship between the domain and the range. Okay, so it's going to show a relationship between the domain and range. And then y'all, the last definition is a function. So a function is a correspondence in which every domain value so every domain value corresponds to one and only one range value. Okay, so that means the x's can only have one Y value. So what we start out with, they're going to give us some of these correspondences, and we got to determine whether they are actually a function or not. Okay. So let me do this first one. So they want us to determine if the correspondence is a function. All right, y'all, let me let one in real quick. All right, y'all. So let me see. This one, they got the domain on the left side. And under the domain, they got 23, 12, and 5. And then over here's the range. And they got 20 and 2. So let's see. The 23 points to the 20. 12 points to the 2. And this 5 points to the 20. So they want to know if this correspondence is a function. So remember, my definition of a function is that the x's can only have one y value. So I'm going to focus on the x's. So the first x is 23. And y'all, if you notice, the 23 only points to the 20. So that means that this x only has one y value. So then let me look at the 12. The 12 only points to the 2, which means that this x value only has one y value. And then I look at the last x, which is my 5. This domain member 5 only points to one range value. So since each of our domain members only corresponded to one range value, number 1 is definitely, yes, a function. Now remember, we didn't say that the x's couldn't share a range value. Our only rule was that the x's could only point to one range value, okay? All right, y'all, so number 2, same thing. We'll have a domain and a range. So my domain is -5, 2, and 7. And then only got one number in the range, which is a 3. So all 3 of these point to the 3. So do y'all want to guess on this one? Is that a function or not?
Yes, yes.
Yes, definitely. Because each domain member only had one range. There you go. So that is definitely a yes. All right, y'all. So we'll play with a few more of these. All right, let's see. On this one, they got a 125, 8, and 27. Over here, I got -5, -2, and -3. And y'all, all three of these are pointing straight across. So that shouldn't be too bad on y'all. Is that a function?
Yes.
Definitely. I mean, that matches the definition perfectly, right? Everybody went straight across. Now, this last one they're using, so my domain on this one is going to be cities, and the range is going to be these different teams. So they got Detroit and New York. Now for the range, they got Lions, Tigers, Pistons. So Detroit was pointing to all three of these teams here. And then New York had Rangers, Jets, and Yankees. And so New York pointed at these three right here. But going off of our definition of a function, is this correspondence a function?
It is, right?
No.
No.
No, good job, y'all. Because my domains are getting more than one choice for that range. And like y'all said, that violated the rules of a function, okay? So remember, a good function, one input, one output, just like your pay. You work 40 hours, you want 40 hours times your salary, okay? And so on. So now let's look at function notation. And that's when you see the f of x. So y'all, the f of x notation is used to let us know that we have a function. So it's used to show a function. Now, if a number is substituted in place of the variable, so if a number is put in place of the variable in function notation, so say I got a function f of x equal 3x plus 2. If I put a number in place of that x in my function notation, then that number is substituted into the expression. For each variable. Okay, so what I mean by that, if you had 3x plus 2, you'll plug that number in for the x. If you had something like x squared plus 3x, then you would plug it into both of the x's in that expression, okay? So it's just basically this is shorthand letting us know we have a function given. So what they'll do on these examples, they're going to give us the function. So say I got something like this, given function k described by k of x equals x plus 11. So instead of using f of x, they're using k of x. And a lot of times, the letter they use sort of describes what the function's for. And you'll see that more in your science classes, okay? Like in science, F might stand for force. So this is just letting me know I got a function. So we got a function k, and they're letting me know that the variable is a x, okay? Now, all we do is work the right side. This just lets us know, like I said, that we got a function, and it's not part of the part we're solving. We only solve the expression part once we put in our number. So they're giving me function k. They want us to find k of 0, k of a negative 17, k of a negative 9, k of 20, and k of a b plus 2. So this is basically 1, 2, 3, 4, 5 problems using this function right here. So k of 0 equals x plus 11. So let's play with this. We got k of 0. And so what'll happen, MathLab will give you these one by one, and you'll just put in your answer and move to the next. And it makes you check them, I think, after each one, okay? So y'all, k is 0. Here we go. They're letting me know the variable is the x. So right here where I got an x, we need to put in a 0 since we're finding k of a 0. So k 0 will equal 0 plus 11. And y'all, 0 plus 11 gives us 11. So that means k of 0 equals 11. So then it wants us to find k of negative 17. Well, all right, put a negative 17 in for that x. So that's going to give us negative 17 plus 11. All right, y'all, so trickier when I got unlike signs. So what do y'all get when y'all do a negative 17 and a positive 11?
-6.
Negative 6, good job. All right, then we got k of negative 9. All right, so put a negative 9 in for the x. I get negative 9 for plus 11. All right, so you got unlike signs again. So what about this one? A negative 9, positive 11.
2.
2. So y'all notice when you add these unlike signs, the answer always has the sign of the largest number, okay? All right, let's see what we had next. K of 20. All right, so putting my 20 in, that's going to give me 20 plus 11. And 2 adding positives not too bad, right? So what's that give me? Looks like 31. But y'all, let's see what y'all do to this. I got a k of a b plus 2. So since that b plus 2 is inside these parentheses, that means over here in my expression where I got an x, I'm going to put a b plus 2. So I get a b plus 2, and then I add my plus 11. Okay, so notice, no matter what they put here, if it's inside these parentheses of my function, I put that whole thing in for that x. So y'all let me see, what would y'all do to that right there? Can you go further on that?
B plus 13.
There you go, B plus 13, perfect. So y'all, all we could do is add those like terms, which was those two numbers sitting there, okay? Alrighty, so function notation, remember, is mainly just shorthand saying, hey, put a 0 in for the X, put a negative 17 in for the X, and so on. All right, y'all, so let me try another one of those. All right, so this one they're giving us H of T equals 5T plus 9. And on this one, they want us to find H of 5, H of a negative 8, and then H of a 6.4. All righty, so if I was going to use my calculator to help me on this one by multiplying, it'd probably be that 6.4 when I plug it in. These two numbers, not too bad. But yeah, decimals, a little trickier to multiply. So let's see, first is H of 5. So take our expression, and where they have a T, we're going to put a 5. So that'll give us 5 times our T, which is 5 plus 9. And you'll notice each of these are going to pretty much set up the same. All we're changing is the numbers, okay? All right, y'all, so let's see, what's this? Multiply before we add. So 5 and 5 give me 25 plus 9. And that's what, 34. Okay. So H of negative 8. So I'm going to take that expression, put the negative 8 in for the T. So that'll give me 5 times negative 8 plus 9. All right, let's see. Positive times a negative is going to make that a negative. And then 5 times 8 is 40. And then plus or 9. So see what you're doing again. We're having to add these unlike signs. Now, the larger number is negative, so I know that'll be a negative. And then let's see, 40 minus 9, what's that? That'd be what, a negative 31. All right, y'all, then look, H of 6.4. Putting the 6.4 in for the T gives me 5 times 6.4 plus 9. So see, they still look like the 5T plus 9. I got a 5, my T plus 9. All right, y'all. So let's see, 6.4 times 5. I believe that's 32, but guess what? We got a calculator we can use. So 6.4 times 5. And yeah, that was 32. Okay. So this gives me a 32. Bring down my plus 9. And y'all, 32 plus 9 is 41. Okay, so you'll see these aren't too bad. It's just, like I said, the calculator can do the 5 times 5 plus 9. Remember, if you're using the calculator, all you're doing is punching in this right side to get that answer. This is just letting us know the number we're putting in, okay? So let's do this one. Find the function values of f of x equals x to the third. So they want us to find f of 0, f of -1, f of 5, f of 9, f of -4, and y'all finally f of a -5a. So let's see, 1, 2, 3, 4, 5, 6 values they want us to find on this, okay? So we'll start with f of 0. Well, y'all, all I gotta do is put a 0 in for the x and cube that. So that'll give me 0 cubed. And y'all, 0 to any exponent is going to be 0. So y'all, f of -1. That'll equal -1 to the third power. So first of all, remember, this is -1 times -1 times -1. If you got 3 negatives being multiplied, what sign will that answer have?
Negative.
Positive.
Oh, I heard it. I think the negative was correct because remember, the first 2 negatives make a positive, but then that positive times that other negative makes that a negative. So a negative number to an odd exponent, y'all, will always be negative. So that's going to give us what? A -1 on that, okay? Right, y'all? F of 5. That's going to equal 5 to the third power. Woo, that's going to be semi-big. 5 times 5 is 25. 25 times that other 5. Ooh, that's what, 125. So y'all, cubes make numbers get big pretty quick. Look at this one, f of 9. So I'll let y'all play with that. And what is 9 to the third power?
729.
729. That's why I wasn't picking 9s on that cubic graph, because those would be some really large y values. What was next? F of -4. All right, so that's -4 to the third power. All right, y'all, so what are y'all getting on that -4 to the third?
-64.
-64. All right, so I guess my tricky one's going to be this f of -5a. So that'll equal -5a to the third power. So play with it in pieces. We know what sign it'll have because a negative to an odd exponent is going to stay negative. We know what the 5 to the third is because we did that part right here a while ago. So we know the 5 to the third will make that a 125. But the question is, what's going to happen to that a?
You're going to bring it down?
I'm going to bring it down. And what else? Because remember, you got an a times an a times an a. So what's that going to do to the a?
You'll bring the cube down.
It'll bring the cube down. Perfect. Okay, because remember, this is like this, right? That exponent is just shorthand for all this multiplying. But remember, each of these a's has a 1 by them. And when you multiply, you add exponents. So 1 plus 1 plus 1 gave us 3 altogether, okay? So y'all remember, everything inside the parentheses has to be cubed when it's following the parentheses, okay? All right, y'all. So now we're going to look at what sort of like a real world example using functions. So I'm going to give y'all a function and see if y'all can figure out what this function's for. So given f of c equals 9/5 c plus 32. Do y'all recognize this formula? So y'all let me tell you what this is, and y'all gonna see this in science a whole lot probably. This formula converts the Celsius temperature. If I know the Celsius temperature, I can plug it into this formula and it'll give me the Fahrenheit temperature. So this one finds the Fahrenheit temperature when given the Celsius temperature. That's why the Celsius is the variable on this one. If I know my Celsius temperature, I plug it right into here for the C's, figure out what 9/5 of that temperature is plus 32, and that gives me the Fahrenheit degrees. So let me show y'all real quick. In Celsius, water freezes at 0. So if I plug a 0 into here, well, 0 times 9/5 is 0. 0 plus 32 is 32. So that tells me that water freezes in Fahrenheit at 32. So you just plug them in and see what you get. So here's what they want on this one. Find the Fahrenheit temperature equivalent to a negative 25 degrees Celsius. So they're telling me that my Celsius is negative 25. So we're going to be finding F of a negative 25. So that means take this little expression here, and in place of that C, you're going to put negative 25. So that's going to give us 9/5 times negative 25 plus 32. All right, now remember, that negative 25, since you're multiplying by a fraction, put a 1 under it, because when you multiply fractions, you multiply straight across. Okay? So this would be 9 times that negative 25. Take that answer, divide by the 5. No, that's one way to do it. But if you remember the other day when I graphed, you could, that negative 25 will divide by that 5. So you could take that negative 25, divide by that 5, and make that equal a negative 5. So let's see what that gives us. 9 times negative 5 is a negative 45 plus my 32. Okay. Now, you could have did 9 times negative 25 and then divided by the 5, got the same thing. Or remember, we got our calculator. So if you don't like multiplying fractions and stuff, I'm going to hit alpha y equals, get my fraction, and that was 9/5. So put in 9/5 And then I was multiplying that by negative 25. So notice on here, we will get our negative 45. And then all we would have to do is add 32 to that, because that was at the end of the problem. So add our 32. So our final answer is a negative 13. All right, so that'd be what we say, negative 13. Okay, so like I said, we got TI-84s. So if you're weak at doing your fractions, you got that calculator, okay? All righty, y'all. So next. And this will be the last thing for the college algebra part of this lesson, okay? So the last thing is they're going to give us a graph to look at, and we got to determine if that is the graph of a function. So what we use to determine if a graph is a function. So determining if a graph is a function. So to determine if a graph is a function, we're going to use what we call the vertical line test. Now y'all remember, vertical lines go up and down, okay? So this vertical line test is what I'm going to use to determine if a graph is a function. So here we go. If a vertical line can intersect a graph more than once, the graph is not a function. Okay, y'all, so think about it. So just think about it. We got a graph here. All right, let me let one in real quick. So say I had something that was sort of like this. Sort of like a sideways parabola. So this is telling me if a vertical line can intersect the graph more than once, the graph is not a function. So y'all watch this. Here's me a vertical line I'm drawing. That vertical line is intersecting it up here and down here. So since, look at this, at this X value, if your graph can get intersected more than once, that means these X values have more than one Y value. And remember, we said that these X's could not have more than one Y value. So this is not a function because this vertical line can intersect it more than once. Now, what if I had something like those absolute values we were doing the other day? Is this one a function? Well, guess what? No matter where I draw, I could draw a vertical line here. It only intersects once. I can draw a vertical line here. It only intersects once. I can draw a vertical line here. It only intersects it once. No matter where I draw these vertical lines, it only intersects my graph in one place. Okay. So since these vertical lines only intersect the graph once, this is yes, a function. Okay. So let me do a few of these and see what y'all think about these. So y'all, you're going to determine if the graph is a function. All right, so how about my first one? All right, there's my X and Y. And this one sort of looks like a parabola. So we drew parabolas the other day for homework. But y'all, my question to y'all is this parabola a function?
Yes.
Good job. Definitely yes. Because y'all, no matter where I draw vertical lines, it only intersects it one time. All right, y'all. So my next one, oh, sort of looks like a egg almost. We call that an ellipse, like a long sort of circle there. So the question for y'all, is this ellipse a function?
No.
No, good job. Because y'all, if you draw vertical lines, it's going to intersect it here and here, all over it. It's going to intersect it more than once, okay? All righty. What about something like that? Is that a function?
Yes.
Yes.
Yeah, y'all, because like I said, vertical lines, no matter where you draw them, it's going to only intersect it once. Okay. All right, so my last one. All right, so this one sort of does like zigzags. Up, down, up, down. So just sort of zigzagging along there. But y'all know the question.
Yes.
Is that a function?
Yes.
Yes, good job. Okay. So remember, the only ones that weren't functions were the sort of sideways ones, the circles. We drew that line and it hit it more than one place. All right, y'all. So that's all the actual college algebra material. So next, I'm going to do some of the problems like you will see in the support homework for this section. All right, so this will be support for 2.2. And this was just getting you ready for those functions when we were plugging the numbers in and stuff. So y'all, let's see what y'all would put here. N minus 6n. What would y'all get? Can you simplify that? N minus 6n.
Negative 6n.
Oh, you're really close. But I didn't like the 6.
Negative 5n.
Negative 5n. There you go. Because y'all remember, if the n don't have a number in front of it, you treat it like a 1 there. So good job. 1 minus 6 was negative 5. And then remember, we never change variables when we're adding and subtracting. When you subtract n's from n's, you still have n's, okay? All right, how about this? 20t minus 15t plus 3t. So y'all simplify that. 20t minus 15t plus 3t.
8t.
Because let's see, that gave me 5, and then 5 plus 3 give me 8t. Perfect. Good job, because a lot of people try to make that into t cubes and all that stuff, but good job. All righty, what about this? Negative times y minus 12. So on something like this, to simplify this one, we want to remove these parentheses. Okay, and that's remove parentheses to simplify. Now, you see a negative in front of these parentheses. So really, when you got parentheses that follow this negative, that means that negative has to distribute through the parentheses. And we would treat it like a -1 being multiplied. So this negative, all it's going to do is change the signs of everything inside those parentheses. So if you do a -1 times y, that'll give you a -y. And then that negative times that -12 makes that a +12. So remember, you're subtracting the y, and you're also subtracting a -12. And remember, when you subtract a negative, that makes it a positive. So y'all knowing that, let's see what y'all figure out on this next one. I got a negative times 57u minus 76v plus 26. So y'all, remove parentheses to simplify this. What would y'all get for your answer?
Negative 57u plus 76v minus 26.
Perfect. Good job. So all we do is distribute that negative to all 3 of those. All righty, so let me throw a little bit of a curve on you then. Let's do, how about a 8a minus parentheses 6a plus 5. So let's think about this one. What's my first line going to be? Now, my first step here is to get rid of parentheses, because you cannot add 8a to a 6a that's inside parentheses, okay? So you cannot add like terms until we remove these parentheses. So your first step is to remove parentheses. So that means you're going to bring down that 8a. So y'all, what goes next? So remember, you got a negative in front of the parentheses. So start distributing
Negative
it.
6a.
Negative 6a. And then distribute that thing to the 5. and we get what, a negative
-5.
5. There you go. All right, so y'all can go a little bit further. What can you do to that?
2A, I mean, yeah,
Oh, you're
2A.
good.
Is it kind of stumped now? Negative,
Just keep going.
3? No, okay.
Oh, no. You're perfect. You did, the only thing you could do there was add those like terms right there. So that 8A minus the 6A gave me 2A. So this -5 don't have an A by it, so we just brought it down to the end. So the only thing what you can do here is combine like terms. All righty, so I'll do one more of these. So I'm going to skip 6. It was sort of like that. And so 7, we have a 10x. Now watch this one. Minus 7, parentheses, 2x minus 3. And then at the end, there's a -4. So y'all check this out. On this one, we got to get rid of parentheses first. Now, since you got a minus and a number in front of the parentheses, we got to distribute the -7 times both parts inside the parentheses. We can't just distribute a 7. It's got to be a -7. So bring this 10x down. All right, y'all. So that -7 times 2x, that's going to give me a -14x. This -7 times that -3 will give us a positive 21. Now notice, both the signs are still going to switch because of that negative, okay? Now this -4 is not in the parentheses. It's at the end, so we'll just bring it down. All right, y'all, so let me ask y'all on this one, what would you get?
Negative 4x. Sorry, I cut out. Plus 17.
Plus 17, perfect. So we added those like terms with the x's, and then the numbers were like terms. So we added these and got the -4, did those and got our 17. So y'all, that's all the support's doing, is just getting you used to the parentheses stuff and adding those like terms. And then, like I said, this very first one, they want you to realize that that's a 1 in and not a 0 in, okay? So y'all, not too bad today. That's your 2.2 college algebra, 2.2 support. Now, next week we'll get into doing a little bit more algebraic type stuff like this, and deal more with finding domains and range and all that fun stuff. So it sort of eases off on the graph in a little bit, as far as us having the graph in math lab, okay?
Okay.
All right, y'all. So any questions?
So the homework, I see you have days up there. So the homework ends, you close it out on the 28th.
Well, to keep on pace with me in the class, those Sunday night deadlines are for the work for that week, and that
Okay.
keeps you on schedule with me. I do have it clicked for y'all to work past the due dates on them, okay?
Okay.
So it'll let you work. The only thing you can't work past due dates on is the actual test. But anytime during the year, if you figure something out, you can always go back to old homework and improve them grades if you want to, and so on, okay?
Okay.
So did y'all have any questions over homework?
I just want to know what we've completed 2.1 and 2.2,
Uh-huh.
and we're moving on. This is actually Kiara Eskridge. I was able to join your class today. Remember I told you I was having some trouble.
Okay. Yeah, so we sort of did a restart from last week since the weather messed us up. So we just doing 2.1 and 2.2 this week. And if you'll look in Blackboard on the left side, it'll say course content. There'll be some lecture videos. I'll have a video from Monday's 2.1 that you missed in there also.
Okay, thank you.
Okay. So we sort of start out mellow this first week, because of all the dropping in ads and stuff. So I don't get too quick on my first week. Eventually it sort of picks up a little bit in the class, but just stay on course and y'all be fine to go, okay? And usually people that finish the course pass the course. So y'all remember that, okay? Alrighty, y'all. So I'm not seeing any questions on my chat or anything. So I'll stop my recording and I'll send this one out later.